Hey there! In this lecture, we're going to talk about conditional statements. But before we talk about that, let's talk about the concepts we have studied before, like the program. We know that the program is a set of instructions, and we use a programming language to write a program to write these instructions in a particular sequence. So these instructions are interpreted in a sequential manner. Just like any other instruction, we instruct someone, and the person or that computer follows that instruction step by step. If we want to understand the sequence, so we're going to see that how a program is executed, how those instructions are interpreted and executed out. So the program follows a sequential manner, which means that if I write the code x equals to 9, y is equals to 3, and z is equals to x divided by 3, and then I'm going to print value of z is this. So the program will run from this particular instruction, like this will be the first instruction. It's going to initialize x with the value 9, then it is going to initialize y, and then it's going to move on to z. Let's suppose if I somehow, let's just say if I'm going to replace, if I want to skip this particular statement, this particular instruction which initializes y to 3, then I would have to remove it, because the program will go from the top to the very end, and it's going to read and execute each instruction that it encounters. So the computer reads it like this: 1, 2, 3, then it's going to perform the division, and then it's going to move out. So then we run this, it's going to print the value of z, which should be 3, sorry. So 9 divided by 3 is 3. Okay, so we're going to get a value in floats, and you should remember that since it's a division operation and the values, there's a probability that we can get a value in floats. That's why the output is in a float. So now we know that the programs are run in a particular sequence. What if you have to make a decision in a particular program? Like in this particular example, there is a probability you want to decide as the program is run based on the certain conditions, how you want it, which path should it follow. We know that it is a sequence, but we can decide which sequence it should follow depending on certain rules. For example, what if I wanted to initialize the value of y with 6 rather than 3? How can I do that? And that the decision is not entirely mine, but it will be based on the input or any other condition, you can say. So if I want to change the value of y, or let's say that the value of y depends on x, and it always has to be, the answer always has to be the x, and it should be divisible by y. So the answer should be a whole number, and it should not be in any points. It should not go in points. So x should always be divisible by y. So in order to do that, we need to make sure a couple of things. So, but this is a situation where the program is going to decide for itself, and you need to put in certain conditions for that. This is where we learn about conditional statements. As you can see, we introduce a particular condition, and based on the condition, whether it's true or false, the next sequence of instructions is executed. Considering an example, let's say if we run this particular code which says that if 5 is less than 6, since we know that this is going to return, this operator is going to return whether true or false, then we can use this flowchart to understand. The reason we call this a flowchart is because it's deciding the flow of the program depending on this particular condition. So if 5 is less than 6, we're going to say, okay, that this makes sense, but let's just be a bit more creative and say, considering an example before, we're going to see x is equals to 9, and let's make that 5, and y is equals to 2, and I'm going to make sure that if x is less than 6, then we're going to divide x with y. So this doesn't make any sense, right? So why are we checking the value of x? Okay, so what if you had the condition that the value of z should never go less than 1? All right, so we need to make sure of that by checking the value of y. So if y is always less than 6, which would assure that the y can never exceed the value of 5. By this we are checking that y is never greater than x in this particular scenario. So you should be thinking, why not should I just compare it with y? Yes, you can do that. That will also perform the same operation, and that's actually smart since this will make the code more dynamic. But let's just go with 6 in this particular example. So we know that makes sense, and then we're gonna output z, and let's see. So what we've done, we've just added another additional statement, and we're going to check this. And so okay, so the answer is 2.5, and which is correct. So we have added an additional conditional statement which ensures that we run these particular statements if this condition is true. But let's just say we extend the code so that you get a better sense of how the statements are executed. If I had some more additional statements over here, right, print x, print y, so even though this condition runs the instructions that are mentioned over here, these instructions will continue to get executed regardless of the above conditions. And for this, it is important to remember that the program follows a sequential pattern. So this condition, if it's false, it would not run these two statements, but it would still run these statements because they are not part of this particular condition. And how are they not part? So if you have noticed that there is a slight indentation over here. This indentation ensures that these particular statements belong to the if condition. When you write the colon over here, it ensures that this is the syntax for the if condition. So we're going to write if, we're going to write our condition, and then we're going to use this colon to ensure that these particular statements, this is just the syntax, and the indentation ensures that these statements belong to the if condition. So let's say if I put the value of y to be 7, now the statements should be false. So we should not get this particular output, but we should still get these outputs. Okay, all right, so 5, 7, okay, that is the value, and that's that. So now you know that the if condition introduces the execution of some additional statements based on a particular condition, but does not disrupt the sequential flow of the entirety of the program. That goes with it. And even if it was true, it would run these statements as well. And yes, we have it. Moving on, let's consider a scenario that if we want to consider the option of the flow of statements if it is false, right? So what would happen if y is not greater than false? You need to have a counter statement for that as well. For example, if the result is going to be less than 1 and you need to prevent that, you need to have an else statement as well. The else statement over here ensures the true and false statement. So what would happen if the if statement was false, then instead of this statement, the no statement would run. Okay, so it's a pretty simple yes or no. If this would happen, then this. If else, this would happen. So rather than, it's better to understand it in simpler English language. Like if you're instructing someone, the if condition ensures that you want the particular thing to happen, and the else condition ensures that you want the particular thing to not happen. Okay, so this modulus over here, we call this percentage sign is the modulus. What we're doing here is we're taking the modulus of 10 against 100. It is the same operation as division, but the output is not the quotient, but it is instead the remainder. So whenever we're taking the modulus is when we want to find out the remainder value of the two, dividend and the divisor. So the dividend is less than the divisor, then the remainder would always be 0. So in the modulus, we have the rule which ensures that whenever the dividend is less than the divisor, when we're going to check that then the output will always be equal to the dividend, which is this one. So in this case, it will not be 0, but it will be 10. In order to check that, let's run this, and it should be no, because the output is not 0, it is rather 10. So if I write 10 over here, then it should be true, and the answer should be yes, and it is yes. So this modulus function gives us the remainder, and the remainder is the output. So it's important to remember that whenever we have a remainder 0, which would mean that this 10 is divisible by 100. So that's that. So moving on, we will now learn about writing multiple if conditions. So you can have as many conditions as you like, and for every new condition you have to write an if statement, and the overall procedure remains the same, and you just need to make sure that you have an indentation for the statement you want to execute when the if condition is true, and for the rest part you do not indent anything. And for the record, the indentation I'm talking about is the space over here. And if you're using Colab, it would not be so hard, because the overall functionality ensures that whenever you press enter after writing the condition and colon, then it will make sure that it automatically indents the next line. And the output is 1, 2, 3. So let's talk about else if statements. And in Python we use a short format for them, which is the elif statements. These statements are used whenever you have multiple conditions, and multiple conditions have either true or false values. So the if else statements was used whenever the if condition is false, the else block and the statements written beneath the else syntax are executed. But imagine that if a particular condition is false, and now in the rather than just running those else statements directly, you want to make sure that you want to check another condition, then you need to have the else if statement which checks those conditions as well. So if you want to follow this control path, this is a very good example. What happens here, if the x is less than y, you go to, let's consider this false, and if you go here, so you will check another condition. If you were not using the elif statements, you were using the else statements, you would not be able to check this particular condition over here. So, and then if it is either true or false, it depends, and then according to this particular condition, you will be able to run either statement A or statement B, and then the overall control flow just consequently merges and the program is executed consequentially. Let's consider this example. We have an example. We initialize x with 7 and y with -1. We're going to check these statements, and we're going to run which one is greater, smaller, negative, and we can ensure this by using the elif statements. So this should be, I guess, greater. Okay, that's right. One important point is to remember in this particular else if statements is that among all these conditions, only one statement, only one condition can be true, which will be executed. But if you were using only the if statements, like in this example, there was a possibility that, as you saw, that all of these statements could be true and all of them could have been executed sequentially. So this is possible in the if statements, but it's not possible in the else if statements, and the purpose for that is the else if statement ensures that by introducing another check on the condition.